Alright, so I've been playing around with my numbers, and when you're playing on a Excel spreadsheet, and you highlight shit, gives you, like, you know, the count and the sum and everything. And there's a lot of data's missed when you're playing with computers, because you can override the cell, blah blah blah. I like writing shit down. But literally, if a 0 is a 1, okay, in Fibonacci, and you just go all the way down to that number, the sum is 514229, which is not the next number, but the number after it. Now, that's an awful lot of randomness to mean nothing. I don't know. Do people know that the sum of the first 28 Fibonacci numbers is the 30th Fibonacci number? Now, that makes 514229 very interesting to Kevin. As does this 422106, because together, now there's a linkage between the third and fourth column where they can make a million, and it's been driving me nuts. So I figured out 2 ways to find a million, because computers, and I'm good with data, but that's pretty cool. So I don't know how I'm gonna do this, but the first way right here, I said to myself, let's sum everything in the column from top. They're all zeros of 1, so some zeros of 1 base. If you add all this, if you add the next one, you go over a million, so you stop. And then you add all this, if you go to the next one, you go over a million, so you stop. And then you add all of these ones to 47. Oh, DG. And then you add the 69 at the top, and then all those ones, and then that'll add to a million. And I was like, okay, cool, that's neat. The difference is 0. So then I clicked this, and I said to myself, well, what about if I just pick random things? And that's what I did. I picked the 2 cells I was just talking about, and I took the whole of the front to here, not that one and not that one, and these two. And then I took a big block here. That sums to a million. I don't know what it means. It's just interesting. So that's interesting as well. Again, the difference between these numbers here, okay, like these ones here, like 110 we found a way, 340 is the first way, we use a 16. 660 we use a 17. Here we use a 15, a 15, a 15, and then we go to an 8 arbitrarily for the rest of these. Okay, if I click on it, it'll show you 8 plus. Go to one before it, it shows 15 plus, 8 plus. So that's where I'm at now. Find it interesting? I mean, that's the next one would be a million, and the next one would be over a million. So I like to see where they stop. Interesting. Now 30 rock, 30 step, maybe like, yeah, keep it in a million. 1 in a million. 1 in a million. But yeah, just playing with numbers, and that's what I do. Last day at work for a whole 2 days, and then I can do laundry. Do my own work. But yeah, this was interesting. So over here, I'll talk about this one because I don't want to, but my God. So the books aren't big enough anymore, because to do this, I didn't even start at 0, but I started where I had to. I wanted to go everything under the V. So I just plugged in these numbers that I calculated earlier, wherever the hell that happened. And yeah, so I said to myself, I want a million. So I took the biggest number and I subtracted it, and that's what I got the difference, 167,000 off from a million. Then I took the next 2 biggest ones, and I want to find a sum of the last 2 that can sum to be closest to a million. So I summed these 2 together, and that's pretty close to a million. That's even closer than this. It's only 63,000 off from a million. So I'm sitting there going, okay. Arbitrary subtractions. And I look over here, okay, and then I wanted to do this. I took the sum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 cells here. And that sums to 105,000. So I go, okay, 105,000. If we take it off this 83, you know, because we're looking at a big chunk of this compared to this. So we're taking that big chunk there, and the difference, and comparing this chunk, and then we get that off. And that's really fucking close, I said. So I subtracted them. And then I got that. And then I know that this, I think these 14 cells, no, these cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those 9 cells sum to 1576. Literally. I think it's 13 to, what is it? 13 to 610? Yep. Where is it? Come on. Sum 1576. These guys. So, arbitrarily, I'm looking at this going like, okay, why are you not working today? I'm like, I want 1 million. I'll take the biggest number. Alright, subtract it. Find the difference. And I take the next 2 lowest numbers out of those together. Then I take the starting block from under the V and subtract that from the biggest number. And then I find the difference between, you know, this way and that way to be that, which coincidentally shows up above. I don't know what to make of this, other than it's pretty fucking neat. That's pretty fucking neat. I'm actually gonna, like, take a look to see if anyone has anything ever published about the fact that this is what it is. Maybe there's a useful coinkydink in there that can be used. But, yeah. Don't get me started with Excel, guy. It's like a fancy super calculator. And notepad. So, maybe tomorrow I'll get on a live stream and do math. That sounds like fun shit to do with my time. Anyway, yeah, you know, these guys right here. Woo, woo, woo. Yes, Mr. Pigeon. These guys right here, you know, I added the 8. This one I added a 16. This one I added a 17. And then these 3 I added a 15. I don't know. I was doing some crazy shit there. No, not that one. I'm just saying. 8. Just why it is what it is, who knows? But I like to, you know. Yeah, I was trying some stuff here. Yeah, there it is. My little. See, I'm starting from the 13 in both. I just find that interesting. Anyway, yeah, I do these all in my head. Well, anyway, one time. Oh yeah, this is cool. I didn't talk about this. Look at this. Okay. You got a 1, 1, 7, 13, 110. You're trying to solve for this, right? So I thought about it. I go 1 times 1 times 1 times 7 times 13 times 110 is this, right? And it's 1, 2, 3, 4, 5 things. So let's like average it out to 20, but not. So then you add them, and then you add the reductions. And you get 2142, which is 1 off. Remember how I said the last time? It was 1, plus 17 plus 13 plus 110 plus 2002 is 2143. But if you can't get 7. I mean, you haven't. This would be an 8 instead of a 17, so you need 9. And I can only get. Wait. Yeah, 9. So 4, 4, and 2. Like, I don't know. It's 1 over. I don't even know if I add the zeros. Or zeros. I don't know. But like I said, that's 2142. I go, okay, it's not a prime number, okay? It's kind of important. It kind of got me. So I said, should the result of the terms multiplied and added be shown in cellular notation as a... Okay, so I said, all right, the maximum result for a circle 2142 is a 1 by 2142. So you're going to add 1 to it, and you're going to add double to it. So if I add 1 to 2142, I'm going to get 2143. And if I double this, I'm going to get 4284. That equals something close to a number that I know. I'm 9 off of 6436. Then I said to myself, these are all digits, and it's a solution. And there's the 8 little bubbles I need and the 1 big bubble to get my 6436. So I said, you know, getting a 2142 ain't bad. I think what I did here was I did this. I didn't add the 4 here. That's what I did before. And here I added a 4. Because I counted that as a circle and a slash. So that's a circle and a slash, that's a 4, and that's a 4. I need a 9 to get 17, but I can only get an 8. I already did too much shit to this. I don't want to do anything else to it. Maybe this answer is circled, and this answer is circled, and that circle would eventually be my 2143. But I don't know if you're following. It's pretty easy. That's probably it for math in this. I need, like, these ledgers are longer, so I could probably get more on them, but now we're getting into the lots of numbers. I don't like working with computers. Fuck you, computers.